This is antimatter. And that's matter.
Breaking news. Antimatter and matter have collided to form a massive amount of energy, which in return makes a big explosion. It's like 43 million tons of dynamite being blown up, which is why all matter and antimatter are fugitives. Now over to you, Jeffrey.
Thanks, Margaret. As you can see from the space video, there is nothing left from the collision that happened earlier today. This collision released a bunch of energy to put a bunch of energy. And to put this in perspective, it is like 1 kilogram of matter and antimatter being collided, and that is equal to the amount of energy released when 43 million tons of dynamite is being exploded. Wait, hold on. We just got in 2 pictures, one of a particle of matter and one of antimatter. This is crazy. They must be caught. Margaret will give you more details. Back to you.
This is such an important issue that schools are weighing in on the action. Back to you, Jeffrey.
Okay, class. Today's objective is antimatter. Does anybody know what antimatter is? Yes?
Antimatter is a sort of mere semblance. And it includes antiprotons, antineutrons, and positrons.
Good job, class.
To help you guys understand antimatter further, Dr. Tara Shears from the University of Liverpool is here to expand on it, and Jeffrey interviewed her. So over to you, Jeff.
Thanks, Margie. So, Dr. Tara Shears, what are you researching?
Well, my colleagues and I are trying to find hydrogenic antimatter, and from this, we have determined that the first measurement of the antimatter spectrum. Just the other day, we heard about antimatter particles captured as long as 16 minutes in Switzerland's CERN laboratories.
Oh my god, that sounds completely mind-blasting. So, for those viewers out there who just don't know anything, can you explain to them about the 3 components of antimatter?
No, they can do it themselves.
Ma'am, this is live TV.
Oh, so, in that case, antiprotons are subatomic particles that have the same mass as protons but have a negative charge. And antineutrons are antiparticles of the neutron, and positrons are positive electrons.
Thanks. That's how dangerous antimatter is, especially when it reacts with matter. When they react, a big explosion occurs like you saw earlier today in space, which means that they both have to be kept separate. There are 3 ways of doing this. The first way of keeping antimatter separate from matter is using magnetic fields in a vacuum. The second way of doing this is using lasers to cool antimatter down.
The third way is by using gravity-based systems. Whoa! Jeff just explained how to keep antimatter separate, so now let's look at how antimatter occurs, naturally and in the lab.
This is beta decay. This is beta decay. Just kidding, that's Mom. Grandpappy's house. But these are 2 examples of beta decay. And in a natural process of creating antimatter, positrons are produced by beta plus decay, as you can see in this little diagram over here. And antineutrons are produced by beta minus decay, as you can see over here, in this general area, right here. Any other particles are produced by cosmic rays. Also, all of this is shown in this very diagram right here. And also it shows that positrons are produced in gamma ray. Flash is created by electrons over here. And last but not least, the American Astronomical Society has recently discovered some antimatter residing along thunderclouds, like this one. Thank you for that, folks.
Hello. As Jeffrey just talked to you about how antimatter is created naturally, I will be talking to you about, okay, down here, bring it down here, up to the side, nope, this, nope, right here. Are we good? Okay, no, okay. Anyways, I will be talking to you about how antimatter is created in the lab with my really cool glasses. So, let's do this thing. So here is the diagram, and in the lab we use the laser experiment to create antimatter. And the laser ionizes and accelerates the electrons. As they are moving, the electrons interact, which the electrons are these, the purple, and they interact with the gold nuclei, which are the catalysts. And this interaction produces a positron. And next, the electrons give off energy, and they eventually decay into these states of matter and antimatter. And that is it. So, yeah. Next, let's look at the uses of antimatter. Antimatter is used for several different things. One of the main uses is it can be used for fuel to power the spaceships. And another use is for medical diagnostics, where positrons are used to help identify diseases. This is done by the positron emission topography.
Thank you, Dr. Shim Shim. So, she did an amazing job explaining that, by the way. But anyway, another question has arisen among us, and that question is a secret until we go outside and interview some people in a couple of minutes. Thank you.
Sir, how can understanding antimatter help us better understand the world?
Shut up! Don't talk to me! Ma'am, how could understanding antimatter better help us understand the world?
Hello, I'm from Michigan and I like cheese.
Ma'am, that doesn't exactly answer the question.
Oh, yes, it did.
So ma'am, how could understanding antimatter better help us understand the world?
Well, the hypothetical theory of the Big Bang states that antimatter and matter existed a long time ago, and they annihilated each other, which produced a lot of energy. And but antimatter and matter still exist today.
Thank you, ma'am. You win nothing.
Whoa! What just happened?
That was a bomb exploding.
Wait, I thought antimatter couldn't be used of a bomb.
It can, but I never even said that. But here's why you're right. It cannot be created in large quantities because it requires large amounts of energy. Plus, antimatter can only be used and held for so long.
Well, I guess we better wrap things up before we go. So, for all you losers out there, a positron is not the same thing as a proton, because even though they have the same charge, the mass of a positron's mass is that of an electron. Thanks for watching, and it's been a pleasure teaching you guys about antimatter. Bye, Mom!
Bye, Mom! Hi, I'm reincarnated. Anyway, here's a little interesting fact for you guys. Antimatter is like a mirror semblance of matter, but not entirely. Here's why. If you reflect a picture of me, as you can see right here in the mirror, it is the same image. And if you reflect that once again, it is the same thing. However, With antimatter, it is different. As you can see here, when antimatter is reflected a second time, it is not like the original. So that mirror, that is the third image of Kristen you see, is slightly different from the original Kristen, which is right here. So that is something really weird about antimatter that scientists are still trying to discover why. And thank you.